Hi everyone, and welcome to lesson 6 for topic 7. Today we are talking about drawing graphs, and this is going to be a nice short and sweet lesson. So we're going to start with the first part. We're skipping the launch for today. But the first part of what we're talking about is what happens when you draw a graph without actual numbers. So when you kind of just draw an estimate of a graph. And when you do that, as you can see on the screen in front of you, when you draw a graph without actual data, you're making a sketch. So a sketch can help you visualize relationships. So if we're just drawing an estimate of something, let me pull up our notepad here. These are our notes from yesterday. Just make this a clean slate. So if we're drawing a graph, let's go ahead and draw the X and Y axes. If we're going to draw a graph on this axis, or on these axes, it might tell a story. Like if we're going to say what could we say? The number, actually we're going to say this is the number of roses on my bushes, because I have a lot of roses blooming right now. And this, instead of number, is going to be time. So what happens in my house is typically in the fall, there's no roses. And then they start blooming around December, and then they stop blooming for a little bit of time. And then they lose all their leaves again, and then they rapidly bloom in the spring, and then they stop, and then I pick some of them, and then they grow and even more come, and then they stop, and then the summer comes and they start slowly fading out until it's back until fall again. So this story that I was able to tell with my graph is a story that represents what's happening to my roses over time, but it doesn't tell me exactly how many roses I have. It just says, well, that when we start here in fall, they are slowly starting to come back in, like, maybe into winter, then they go down. So just like what I just talked about, this graph represents my story. So what we're talking about today is basically storytelling with graphs. So here's another situation. It says an athlete measures her pulse during a 50-minute workout. The workout includes a 10-minute warm-up period and a 5-minute cool-down period. Sketch and label a graph showing her pulse rate. So we can kind of guess what this would look like. Whenever you're graphing, you need to first identify the two variables that are being related. So what are we talking about here? Let's read it again. An athlete measures her pulse during a 50-minute workout. So just from that sentence alone, we can see there's two things being measured. One is her pulse, and one is her time, how long she's working out. So one of these needs to be pulse, and one of these needs to be time. And I told you in the past, in case you didn't see the video, anytime you're working with time, time is always your constant. So the constant is always x, and time always needs to be along this bottom axis right here, which means that her pulse rate is going to be the y value. So here's just a reminder that we're working with minutes and pulse rate, and we're going to give them variables t and r, but that's not necessarily 100% pertinent to the problem. We just need to be able to show that, okay, here's the time and here's our pulse. And then the people who are drawing this graph said, instead of doing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way up to 50, we're going to make each interval 10 minutes. So that way we can kind of show a general pattern, but we don't have to be super precise. And that's totally fine as long as you label the intervals. So now we need to look for the keywords that are describing the relationship that we expect to see on the graph. So we have things like a warm up and a cool down. And a warm up would be when she is beginning her workout, and a cool down would be when she is slowing down her workout. So we found that she's going to be doing a 10-minute warm up period. So from here to here, this 10-minute warm up period, we wouldn't expect her pulse rate to be super high, but we would expecting it to be increasing because that's what you're doing as you're warming up. You're warming up your heart, you're getting it prepared to work at a higher rate of speed than usual. And then she's going to be working out during this time and up until the 5-minute cool down. So if she worked out for 50 minutes, that means from 45 to 50 minutes, she was cooling down. So wherever she ends up with her pulse here, we need to have it cooling down back to her normal heart rate when she's at 45 minutes. Now we need to sketch and label this graph. Oh, and we've got a fun character on the screen to help us with this. I know you can't hear him right now, that's okay. So this is telling us to remember that what we just talked about, the workout is 50 minutes long, there's a 10-minute warm-up and a 5-minute cool down. So they're telling you that they're going to have about a 35-minute true workout in the middle of this warm-up and cool down. My suggestion would be to start drawing it from 0 going up to 10 and then or to the 10-minute mark. And then most likely her heart rate is going to be a combination of increasing, decreasing all throughout this workout until she gets to 45, and then it's going to go down. And that's what this calculation here is showing, is that 35 minutes is going to be this workout section in the middle. And my guess is you're probably going to have they're saying a steady rate, but it might even go up and down a little bit, but it'll probably be pretty constant in the middle. Okay, so we know now we have a 10-minute warm-up, 35-minute workout, and a 5-minute cool down. So now, and finally, we can go ahead and graph it. Now, here's an interesting portion to remember. When they graphed this cool down, or this warm-up, they didn't start at 0. Why wouldn't they have started at 0, 0? Hopefully you said because the athlete's heart rate was not at 0 before they started their workout. The athlete's heart rate was somewhere in a range, maybe between 60 and 80 beats per minute, and that's why they're starting it here. If this was at 0, that wouldn't make sense for our situation. So we started her normal pulse, and then we have to warm it up to a higher, her heart rate's going to be warming up to a higher rate. Now they're just going to make this a steady rate, that's showing that she's going to be working at a steady rate. Realistically, it's probably not 100% accurate. She's probably fluctuating a little bit here, but for the purpose of a graph, that's okay. And then we're going to show the cool down, that she's going to go back somewhere around her original pulse rate right here. And that's a steeper drop because she only cools down for 5 minutes here. And hopefully that makes sense to you, how we were able to generate this graph. Even though we don't have numbers for her exact data for her pulse, we were able to generate this graph using the information we did have. So now I want you to try this in your book for your student companion book. Pause my video here and then try it on your own. All right, so let's go ahead and take a look at this example here. So we have the two variables, or the two things that are being measured, are time and volume. So the amount of rain and the time that the rain was falling. So the rain falls for 6 hours, means that the volume of water in the bucket is increasing over that period. And then the rain stops for 5 hours. So that means there's not going to be any more water added. So it's going to be a constant line. And then rain falls for 1 more hour means that the volume increases again. So if we're going to sketch this, I'm going to have no rain or no rain in the bucket. It's going to rain. We're going to increase. It's going to stay constant, and it's going to increase again. All right. For our last example we're doing together today, we have two different situations describing actions that are happening after school. So option A, or action A, is you leave home and ride your bike to the library where you stay for a while, and then you ride to your friend's house. Notice that I cut out reading that center section because as soon as I saw you're riding your bicycle to the library where you stay for a while, doing research for your science report isn't important to our story. We don't need to know what we're doing at the library. We just need to know we were there. So if that helps you while you're thinking about some of these problems, try to find stuff that's not necessary and literally cross it out on your page or get rid of it so that it doesn't distract you from what's happening in the problem. For part B, it says you ride your bike home. On the way home, you stop at a friend's house for a while and then go straight home. So now we need to go to the next screen and see what we're going to be matching these graphs. So we need to figure out which one is A and which one is B. So let's look at the interval or the labels here. We have distance from home and the time. Remember, time's always on the bottom. So distance from home. So let's look at this graph here. When we're here at 0, 0, this means that we are 0 miles away from home when we start. And then this one means that we are farther away from home when we start. So which one of the stories starts with us being at home? This one says you leave home and ride your bike to the library. This one says you ride your bicycle home from soccer practice. So which one started with us being at home already? Hopefully you said it was A, and then let's try this one at B. And then let's just look and make sure they make sense. So for A, you leave home and you ride to the library. You stay for a while where you do research, and then you ride to a friend's house farther away from home. Okay, that works. Let's look at B. You ride your bike home from soccer practice, but on the way you stop for a while and then you go home. Yep, so B works too. All right, so here's your first got it in your book. Go ahead and pause the video here and see if you can get the answer. Each graph describes the height of a candle over a certain period of time. Which graph is not a reasonable description for this situation? You light a candle and let it burn until it burns out. So here's the height of the candle and here is time. So this would mean that no change happened, a lot of change happened, no change, a lot of change, no change, a lot of change. This one means it's a steady decrease until it goes all the way down to nothing. And this one means the height doesn't change, but the time keeps going. Hopefully you said, oh, I disagree with that answer. I think it is, oh, which is not a reasonable, okay, I missed that, which is not a reasonable description for the situation. Yes, so 3 is not a reasonable description of the situation because as the candle burns, it's going to change. It's going to decrease in the height because the flame is burning away that wax. It's going to be getting lower and lower. Personally, I think 2 is the correct graph, but I could see how 1 might be an option for maybe a really big candle. It doesn't have enough to change and then maybe it gets lower. But I really think 2 is probably the best option to represent that graph. Okay. We are going to skip the second got it and move into your close and check. So go ahead and find this close and check in your student companion book. And then we are going to do just numbers 1 through 4 today. And 4, you're going to create your own story. So draw a graph and tell me what it represents. When you're ready, let's go ahead and take a look at the solution. If you're not ready, go ahead and pause the video, no problem. Here are the answers if you want to pause the video here to check your work. Thanks for watching all my videos for topic 7, everybody. I look forward to seeing you in topic 8.